So from router number 1, and let's do one thing, router 1 and router number 2 and router number 3. Again, we have a loopback behind the 3. That's a 3.3.3.3.3. We have this guy is a 12.1, and this guy is a 12.2, and this guy will be 23.2, and this guy will be 23.3. So the network I'm going to use in between is a 12.0/24, 192.168.12.0/24, right? And this guy I'm going to use 192.168.23.0/24. Okay. Now what happened? From router number 1, if I say the ping 3.3.3.3.3.3.3, right? The MAC address of every interface, we have a this guy's a B, this guy's C, this guy's a D, and this guy's a F, right? E. So if I say the ping from router number 3, right? If I say the ping from router number 3, how the router is going to process the packet? In this case, what happened? First of all, router 1 is going to create a packet like this. We have a source MAC information that will be A, of course, right? Destination MAC will be what? Of course, the B will be there. Already we have if you don't have a ARP entry, it will resolve the ARP, right? Source, then after that we have a type field 0x0804. That's going to represent I need to forward the packet to the layer 3, right? Source IP will be what? It should be 12.1, and destination IP 3.3.3, right? And normally what happened after that, we have a TTL field over there. The TTL will be 255, right? Okay, this thing will be present. For your kind information, I'll let you know, write down one thing. If TTL is modified by router, it means that checksum had changed, right? If TTL is modified the router by the router, it means that the checksum had changed. Then yeah. Get it? Clear? Now try to understand. The first line is saying that normally what happened, if you see, I'll show you this thing. Ethernet header, right? In this Ethernet frame, if you see, this is the actual frame we have, right? We have a preamble, we have SFD, we have a destination MAC, we have a source MAC, we have EtherTap, we have a payload, and we have a FCS. Multiple things are there, right? But whenever you do the Wireshark, if you just have a look, start and take cap console and this console, and I'm ping from here, and let me capture this link as well. R1, R2, capture this link, start capture. Interface 0/0 IP address will be 101.1/8 no shutdown R2. Interface 0/0 102/8 no shutdown, and so this is not IP address, right? So we have a 101, and this guy's a 100, right? So if I'm going to ping from R1 to R2, right, do ping, and if you see the capture, what happened? If you open the echo request packet, In this frame, Ethernet frame, what information we have only? We have a source MAC information, we have a destination MAC information, and we have a type field. Only this information are there, right? Don't worry about this bit. What is the LG bit? What is the IG bit? I will explain this part in the multicasting, right? Not now, okay? But only the three fields are there, right? We have either source MAC, distance MAC, and type field. But if you check the frame, what are the frame is happening? We have a preamble, SFD, and the ether type payload and FCS, right? What about this guy? Guys, this guy is never present in your frame, right? Whenever you do the wireshark, this is the hidden part. This part will be hidden. This part will be hidden. But router is processing each and every part. This part is hidden, but router is going to process each and every part, right? So when the packet, listen to me, when this packet, right? When this packet, this is a source MAC, distance MAC, type field. The type field is a 2-byte field, right? Source IP, distance, and TTL. So when a router, right? A router receive the frame, check the receive frame check sequence, right? FCS. When a router will send this packet to the other guy, right? On the layer 2, what happened? This is the frame, and this is the packet, right? So what happened when the router will receive this frame on this particular interface 0/0? What they will do? First, they will perform the frame check sequence, right? First, they will perform the frame check sequence. And in the frame check sequence, what happened? They will just check the, do we have an error or not? If you have an error, frame will be discarded, and router is not going to attempt any recover of this thing, right? I'm just detecting, is there any error? Error detecting or error correcting, both are different words. Detecting and correcting. Okay, I'm only going to do on the error detecting. If the error will be present, I will just discuss this frame, right? After that, what happened? Take example, if there is no error, because if you have an error, then packet will discard, right? And if you don't have error, then the router check the ether type field. That's the most important, right? Based on that, I need to decide, should I forward the packet to the layer 3 or not? That's a 2-byte field, right? This guy 0x080 is going to represent, it's a IPv4, right? See, and trailer can now discard it. Now we have done with the data link layer based on the type field. Now they will remove all the header from the data link layer, and now the router is going to process which guy? Layer 3. Assuming an IPv4 packet, it's a header checksum first verify, right? Now listen to me. On a layer 3, we have a payload and we have a IP header as well. I'm going to do the header checksum only for the IPv4 header, not for the payload. I'm only going to do the checksum only for the IPv4 header, not for the payload. In case of the mismatch, the packet will be discarded. Again, this is just error detection is happening. I'll tell you one thing, your checksum will be modified, right? As I know, your checksum will be modified if you modify with a TTL or your IP. If these two modifications, see, anything will be done, your checksum will be changed. Mostly what happened, if you have a NAT, IP will be changed, your checksum will be also changed. Always router is modify the TTL. In that case, what happened? Checksum will be changed. Now, what happened? Assuming that this is the IPv packet and header will be checksum, right? If the header or checksum will be verified, in case of mismatch, the packet will be discard. I'm not going to do anything. But if you have a IPv6, this checks will be skipped. Reason is very simple, because IPv6 does not have a checksum field. The reason is very simple, because on a layer 2, you already doing the verification, right? in IPv4 format, what happened on a layer 2, you also doing the verification of checksum. On a layer 3 also I'm doing, and layer 4 also I'm doing. So every layer is doing, right? So what IPv6 is doing normally, IPv6 is, hey, if you do the layer 2 and if you're also doing the layer 4, why should you need a layer 3? So just remove the checksum from the layer 3 in the IPv6. So if you have an IPv6, this field will be, the step number 3 will be skipped, right?
Hello, no, one question. So this checksum you're telling, right? What is it checking basically? The header. What kind of?
See, actually what happened whenever the host will send a packet, right? So it will calculate the checksum of the complete header, right? The like the MD5 digest value. The we are finding we are just whenever we're putting the password over there CCIE. So what happened? They will just, let me show you this part. 1 minute. MD5. Exactly right. This will be put on the once complement. It will be doing it also to once complement. Sorry. Yeah, internet is not working in. MD5. Yes. Can you see what I'm getting for the MD5? The string is CCI, and what I'm getting, what hash value I'm getting over there? This one. So what happened? Same like a checksum is going to work. It's not like actually MD5. The same like a checksum is going to. What checksum is going to do? It will perform the once complement of the header, right? If anything modification is done. So what happened if the user is going to do the checksum of the header? What happened? The receiver also going to do the checksum of the header. If they both will be matches, then it will, the packet is good, right? If the both will not match it, the packet will be discarded. It means someone has modified the packet. This is the checksum is going to work, but it has a long process, right? It's very long process. If you just Google it, like how the once complement is working, this they are doing actually once complement. If you just Google it, how the once complement is working, it's a very long process, right? And we are not going to try to understand that process, how these things are working, right? As for networking, we are not going to learn how these things. If you did your BTech, right? In a BTech, I did this part, right? In electronics and telecommunication, right? We have one separate chapter over there, right? Of the checksum, how the checksum is modification is that done, and how you can calculate the checksum as well as. So checksum is just simply like what happened. They will just find the one value. If the same value will be matched on the another side, it means that I will accept the packet. Otherwise, I will not accept the packet. This is a simple word I can say that, Swami. This point is clear.
Yes, Flo. Yeah. So basically, before sending it, there's a checksum that's calculated, and after sending, there's a checksum that's calculated, and they are verified, and they basic. Okay.
12.1, and this guy's 12.2, this guy's 23.2, and this guy's 23.3, and this guy's a MAC address A, MAC B, MAC C, MAC D. This through loop back, and I see the ping from R1. Right now, what happened if the header checksum is passed? Now the router checks whether the destination IP address is present on the router itself or not. What was my IP header was there? The packet. The packet was something look like this. We had a source MAC A, destination MAC will be 0x0800, source IP will be 101, 12.1, and destination IP will be 3.3.3.3, right? And the TTL was 255. If the header checksum will be passed, right? The router checks whether destination IP address is present in my routing table or not, because this packet is coming to the R2, right? R2 will check the routing table. Do we have a 3.0.0 in my routing table or not? Of course they have. If you have a routing protocol is enabled, right? If you have a routing over there, you must have this information, right? If does the packet has just adapt to the destination and router analyze the protocol field, that as a layer 3 field, we have a protocol field, right? And based on that, they will decide should I forward the packet to the layer 4 or not, this field. So right now it's still ICMP, right? ICMP works on the layer 3, right? If you have a TCP and UDP, you have a different values over there. So the protocol field on the layer 2, we have a type field that is going to determine should I forward the packet to the network layer or not. On the layer 3, we have a protocol field that is going to tell you, hey, should I forward the packet to the layer 4 or not? On the layer 4, what happened? We have a port number, right? So once we have done this part, if it does, the packet has just adapt to the destination and router analyze the protocol field in the IP header, identifying just the upper layer of the packet, and they will just hand over to the upper layer. The destination is not matched. If the destination IP does not match, then what happened? Router configure address, the packet must be routed. The router first verify the detail. 1 minute. It's a withdraw. If the destination the router has been without, the router first verify the TTL packet given one. If they're not, the packet is dropped. 1 minute. Oh, sorry. The line is right long. What happened? The IP destination IP, right? IP destination IP address does not match of the router configure interface. Router configure interface in the sense of what? The does router to have a 3.3.3 IP address or not, right? The router for if it is present, right? The router first verify whether the TTL of the packet is greater than 1. If not, the packet will drop and it will send the ICMP time exceed message over there, right? If the TTL has to be greater than 1, if it will be 0 or less than 1, what happened? I will drop the packet. If more than 1, then I will drop the packet. The router checks the IP routing table for the most specific prefix and match the packet to the destination IP address, right? After that, what happened? Once this will be passed, right? Step number 6. If the step number 6 will be passed, then match routing table entry include the outgoing interface, right? Of course, every routing table has an outgoing interface with the next hop. If the next hop will be not present, then it will perform the, sorry, if the exit interface is not present and if only the next hop is present, then it will perform the reverse lookup, right? Static routing, CCNP. This information is used by the router to look up the next hop information to the layer 3 and appropriate the mapping table. Like we need to perform the layer 2, right? It will look up the ARP if you have a Ethernet technology. If you have a like a frame relay, then it will go for the Del C, and depend on the technology, it will look up the layer 2 information. Why do we need to perform the lookup for the ARP and Del C? Just build the new data link frame. Because once I receive the packet on this particular interface, I need to route this packet from this interface, right? And once I'm going to route this packet from this interface, what happened? I will have a new header. We have a different source MAC C, different destination MAC D. Source IP still will same remain, right? The 12.1 destination IP will still remain 3.3.3, and TTL will be just decrement via router 1, router number 2, 254. So for this perform the to create this new header, right? To create this new header, I need to look up the ARP. If you have a Ethernet technology, if you have a frame relay, I will go for the Del C. This lookup is needed to just build the new data link frame. Once this will be done, right? Once this will be done, what happened now? Before creating a new frame, the router update the IP header of the TTL or hop count. Both are the same meaning, right? And what happened? Requiring the recomputation of the IP header checksum. So on the layer 2, I'm also going to verify the checksum. On the layer 3, also I'm going to verify the checksum, right? The router then encapsulate the IP packet in the new data link layer header. That is this guy, right? And including the trailer, and create a new frame. And now it will send this information to the router number 3. When router number 3 will receive the same packet, what happened? Again, it will perform the starting process task. This one, the step number 1. Router will receive the packet. Sorry, router will receive the frame. It will perform the FCS. If everything will be correct, then it will go for the step number 2, and it assuming the IPv4 packet. Then it will look for the protocol field, TTL field, check some verification. Again, do the lookup for the layer 2, and then again it will forward the packet to the router number 4. So if you have 100 routers in between, what happened? Every router is going to do the same task, right? For how many packets? For all packets. For all packets, what happened? Listen to me. So if your router will send a 1000 packet, for 1000 packet, what happened? When the router will receive the packet, right? It will send this packet on the router. What happened? We have two things. One, we have a route processor, and one, we have a switching engine, right? On the route processor, what happened? We have a routing table information. On the switching engine, what happened? They have an interface number. Where should I, to place the packet? So when the packet is received on the switch engine, what happened? They will send this packet to the route processor. Route processor is like a CPU of the router. So if router will receive the 1000 packet, right, it will send this packet to the CPU. CPU will perform every lookup over there, and again the CPU will send this packet to the switch engine, and switch will forward the packet to the another interface 0/1. So every time, right, every time whenever the router will receive the packet, right, it will receive by the switch engine, right, and switch engine will forward this packet to the route processor, right? Route processor is a CPU like it will perform every lookup over there, and again it will send the packet to the switch engine, and switch engine forward the packet to the 0/1, and this thing will be done for the 1000 packet. In this case, what happened? I'm just increasing the CPU. So can you imagine in just a 1 minute, if you're just surfing a web browser and you just put the google.com, right, and if you're just watching the YouTube, how many packets you're sending from your PC? Lakhs of packet, millions of the packets you're sending from your PC, right? And if every packet is handled by the CPU, what happened in that case? CPU will be high, right? And if your CPU will be high, if your router processor is not working well, maybe the chance of congestion will be there, right? Of course, if I'm not going to process all the if I'm not going to process all the packet, network will be congested, right? In the switching meanings of the router over there, it means that I just need to place the packet from one interface to the another interface. Place the packet from one interface to another interface. That is the meaning of switching. Place the packet from one interface to the another interface. That's the meaning of switching. And route processor, what route processor is going to do? It perform the lookup for each and every single thing. This was the process switching. As the name suggests, right, in a process switching, what happened? For every single packet, I need to do the process lookup by the CPU. Every single packet is looked up by the CPU, not by the the router. Every packet the CPU is going to look up, and all the subsequent packets there, right? All the same packet we have, so same IP, same destination, same IP, same destination, same DSCP field, IP field, right? Everything is same, but still all this packet is looked up by whom? CPU. So to avoid this problem, what we have introduced after the processing, we have introduced the concept of fast switching. In fast switching, what happened? After the processing, in the fast switching, what happened? If you have a 1000 packet, right? If you have 1000 packet, only the first packet, if you have a 1000 packet, right? Only the first packet will go through process switching, that we can say that CPU, and remaining packet, all the subsequent packet will send by route cache. See, if I'm going to tell you one thing, basically we have only two types of switching mechanism. Either we have a process switching or either we have a CEF switching. Route cache is just an advanced version of the processing, we can see that, because still in the route sorry, in the fast cache, what happened, fast switching, we still preferring the process switching, right? And what happened once the one packet will be processed is what happened once the route processor will receive this information, what they will do, they will send the one copy of database to the switching engine, right? And in the switching engine, what happened, they have a one memory over there, and in this memory, what happened, they will put this information. Okay, if the source IP is coming from the if the source IP is 12.1 and destination IP is 3.3.3, I need to route this packet from the 0/0 interface. I need to route this packet from the 0/0 interface. So this information, what happened, RP will send, route processor will send to the switching engine, right? So whatever the packet is coming to the switch engine first look up the, do we have this information? Yes. So now let's send the packet through the switching engine. Now I'm not going to involve the route processor over there for the 999 packets. If they have a source, same destination, same like a DSC field, right? I'm not going to entertain the route processor now for the remaining packets. This is comes in the fast switching over there. So after the process switching, the fast switching was good, but in the problem, the fast switching, I'm utilizing the memory. I'm utilizing the memory of the router. So take example, if the capacity of the router, right? Take example, if the capacity of the router is only going to contain the 500 routes in the fast switching cache, right? That is known as a route cache as well as. In the route cache, if I'm going to only put the 500 entry, what happened? The next 501 entry will be what? Process switching. If my router is only having in the 500 entry, what happened? The next one, the 501, right? But all this thing is a dynamic entry. It's not a static entry. So if you're sending a huge amount of packet, right, that is not handled by the router, the route cache, what happened? They will do the processing. So this was again a problem, right? So after that, they what happened? The Cisco introduced the concept of CEF. After this problem, Cisco Express forwarding. Cisco is given, it means that this guy is only going to run on the Cisco devices. Forwarding means what? I need to forward the packet based on the CEF. So CEF is what? It's not a protocol, first of all. It's not a protocol. It's not a protocol. It's a IP switching mechanism. IP switching, what is the meaning of switching over there? Place the packet from one interface to the another interface, right? That's the meaning of switching. Place the packet from one interface to another interface. That's the meaning of switching over there. For example, router one, this is the interface and this is the interface, 0/0 and 0/0. sorry, 0/1. So if the packet is coming on the 0/0, so it will do, it will place the packet from here to here. So CEF is what? CEF is a not a protocol, first of all, it's a mechanism of switching. It will just switch the IP packet. And what CEF is going to do, CEF itself is going to create a CEF itself going to create the two tables. One we have a forwarding information base, that is known as FIB, and one we have a adjacency table, that is a layer 2 table. So it's a layer 3 table and it's a layer 2 table. By default, CEF is enabled on the server. You can disable this thing if you want. If you want, you can disable this thing. By default, one more point, just make a note point this guy. By default, CEF is doing per destination load balancing. Whereas process switching was doing not doing, we can enable the processing as well. So doing per packet balancing.
One question, Law. So now when you say that CEF is doing Cisco Express forwarding, right? So if there are on the destination, if there are multiple interfaces on it, like then it kind of understands the MAC address and that's the ARC table and then goes and does the forwarding, or how does it do that forwarding?
It will now the lookup from the not from the routing table, not from the ARC table. Now is going to perform the lookup from the forwarding information base and instance table. Forget the routing table now. Till this point, what you have learned, that you have learned routing table.
Oh, okay.
Now they have a own table. It's CEF forwarding information base. It's ditto like your routing table. It's a mirror copy. We can mirror copy. So whatever the information are present in your routing table, same information will be there in the CEF table. So when the router, if the CEF is enabled, right? If the CEF is enabled, right? If CEF is enabled, router need to forward the packet based on CEF table, not on. And CEF must be enabled. कंप्लेंट करना जाके एक क्वेश्चन मुझे I have a quick question to all of you. Router 1, router number 2. router 3. If this packet is coming, source MAC is A, destination MAC is B, 0x08.0, source IP is 12.1, and destination IP 3.3.3.3, right? Right? If this packet is sent by the router number 1 to the router number 2, right? Router number 2 will receive this packet 0/0. As I told you, if the TTL will be decremented, right? Checksum will be changed. So checksum to change again. यहाँ पे 254 आ गया. Huh? Yeah, after. When the router will receive the packet, then it decrement the detail. No, after processing. So अब जब ये मेरा detail decrement हो गया, तो late to frame कैसे check हो गया? Late to frame में भी checksum होता है. तो उसको ड्रॉप करना चाहिए था late to frame को. Just check. I was just checking, right? You learn this thing or not properly. Layer 2 में checksum होगा, layer 2 पहले checksum करेगा ना. If the layer 2 checksum will be successful, then it will go for the layer 3. And if the layer 3 is successful, then it will go for the layer 4, ना. Yeah, यार, कहाँ ध्यान है तेरा यार? Yeah? Okay. So CEF is a mirror copy of the routing table, right? So whatever the information is present in the CEF table, for example, this is my routing table, and this is my CEF table, right? Forwarding information is. So the routing table, if you have an information, for example, 1.0.0.0.0, same information will be present in the CEF table, 1.0.0.0. If the routing table has a 2.0.0.0, the same information will be 2.0.0.0. If the routing table has a 3.0.0.0, same information will be 3.0.0.0. Ditto copy, mirror copy. If the routing table does not have 1.0.0.0.0, CEF also not will have 1.0.0. If router will receive a one update that have 4.0.0.0, they will make this entry in the routing table, right? So also what happened, you will have an entry in the CEF table. So whatever the things will be present in your routing table, same thing present in your CEF table as well as. But on a router, this command is enabled, IPsef. And because of this reason, router is maintaining the FIV table and adjacency table. What happened if I say no IPsef? So immediately what happened? This will be now I have disabled the safe. And what happened if I'm going to disable the no IP routing? Then also this will be deleted. Clear? How the CEF is
Didn't
working
we have to do that on the H3 lab?
on the server side?
Yes.
Yeah.
What was the reason for that? Do you remember?
To make a router as a if you're not going to disable IWAS, I had to make that server as a behave like a host, right? Not the router. So on the time, what happened? I'll tell you. The configuration was IP routing, and that's why what happened. They are not able to ping. You need to disable that thing. This was the troubleshoot was given by the CCIE. फेल हुआ था ना तो उसमें इसके लिए नहीं फेल तूने कर दिया था ये Ron, there is a one guy over there, right? He failed in the S3 lab. तारीफ कर रहा हूँ तेरी. So he forget to yes.
Yeah, please go ahead. I mean, I just want to understand, like, why did we have CEF here? I mean, it's still doing the same job as the routing table, right? So,
but in this CEF, what happened? I'm not going to look up the routing table, right? So do I need to perform the CPU over there? I'm not hitting the packet of the CPU, right? Yeah, I'm just copying the data. It is something like that. Look, as a Swami, right, is the manager of the company. At the same time, तेरा नाम क्या है भूल गया मैं Chetan. So Chetan is the PE of the company, right? Or Chetan the PE of Swami, right? So what happened? Either whatever the employees are sitting over there. So this is the Ron, right? Devender, Law, Ancha, Srikant, और ज़्यादा नहीं लिखा जा रहा है ठीक है समझ लो so what happened either two things will be happen right either every person is going to the Swami hey Swami just give me the 1 day leave right so what happened in this case Swami will be have a lots of pressure right because he's a manager Swami manager उसी से मैं छुट्टी लूंगा ना Swami को जब hey I need a holiday either Swami will do one thing Swami said that hey whenever they are asking for the chutti right just stand in front of the Chetan right so now what happened everyone is trying to ask to the Chetan hey Chetan give me the holiday not to the Swami so this is your CEF and this is your routing table so if I'm going to disable the CEF what happened if I'm going to remove the Chetan so everyone is now going to the Swami right right so this is that so Swami now you understand this part
Right. So it's basically caching all the records.
yeah exactly now you understand caching all the recording
Okay, but that way the memory is getting consumed, but that is okay, right?
that is okay right I'm not going to consume the CPU
So when they say software switched, right? Sometimes they say that it's a software switching is happening. So what does that mean?
software that's the meaning of CEF I think so I'm not 100% sure I'm not 100% sure let me check that's a switching engine that we have done, right? The router has the two things. So when we have route person and we have a switch engine, right? It's the same thing. What is switching? What you said? Switching in what you said?
Software switching. They say that CPU का ये utilization है because it's software switched करके बोलते हैं.
ये देखो या तो the thing is that maybe this is the same thing as CEF is happening. Maybe I'm not 100% sure because this word is new for me. Okay, I haven't read this one. I know the DCEF, right? This that like you have to do on the distributed CEF. DCEF is understand like the high end stage of router you have to do the DCEF. But software switching, okay.
So basically, they say that hardware switching is your CPU wala switching, but software switching is where I can't remember straight away, but yeah, I think there's something around there.
कोई ना मैं कर दूंगा I'll do that for you, don't worry.
All right, thank you, sir.
Maybe where you did this part? Somewhere else, like any book, anything?
No, sir. Basically, I was involved in one of the tag cases because I'm a consulting engineer, and they called me up, and I think the tag team was troubleshooting, and they were informing the customer saying that the packet is getting software switched. So I can't remember.
Spidey was CEF with them, 100% CEF is there happening.
Yeah, so it was definitely not on the data center. It was on the route, our ASR routers, I think. That's what they say.
That's not real. It's just a term is different. I'll check it that term and let you know.
Yeah. So I'm thinking if this has got something to do with the CEF. That's right.
Maybe we are right. So let me check with the cross check it. Maybe the name is changed. Okay, that's not a big deal. Hardware switching, processing, software switching. I think software switching is CEF switching, right? Because hardware means what you are going to look at the routing table. Software is a CEF. Yeah, 100%. I'll check it and I will confirm you. Don't worry. Show
Yes.
IP routes. Show IP CEF.
So Amit, then what is the difference between CEF and fast switching? Fast switching also is consume memory.
Sorry.
Difference between CEF and fast switching?
CEF and fast switching. In the fast switching, what happened? What was the issue with the fast switching?
Memory.
If the 1000 packet is coming, right? If the 1000 packet is coming, in the 1000 packet, only one packet will go through the process switching, right? And all the 999 packets will go through the one cache table. But the problem is that in the fast switching, you will have a cache table, right? And the limitation of the cache table will depend on the memory of the router, right? But there's still one packet is to do the process switching. So if you have if the PC is going to generate the 20,000 packet with a different destination, what happens? All these packets will go through the processing. CPU will be high again, right? So our main difference in the CEF is what happening. In a CEF, I'm not going to do the any like a CPU lookup for the any of the packet. All this packet will go through the CEF. All this packet will
What
go
if?
through, right?
But what if the
Yeah.
if the database does not have the destination at all in the cache? Then
Yes,
it has
table.
yeah, in the CEF table. Then it has to go to the
Of course, 100%. If the CEF is not able to find, then I need to do the CPU. It is seem like if your PA is not going to work for like for that guy, so what happened? Now the guy will go to the manager.
So for CEF, we are not consuming memory. Like,
Of course, we are consuming. It's not like who said it's not consuming. We are reducing the CPU.
okay. If memory gets full, again it fall back to process CPU, right?
Of course, if the memory grid will get full, then it will again back to the processing over there. In the same see 1 minute. How does the memory will, if your routing table will be full? Of course, your CEF will be full, right? Right now, because I say that CEF is the mirror copy of the routing table.
Okay, right.
CEF is the mirror. So if your router capacity, if your routing table capacity is a 10 routes, CEF also we have 10 routes, right?
Yeah, right.
Now have a look. If you see the server IP CEF, we have a forwarding information base, FIB. So if you see, we have a 1.0, we have a 2.0. I don't have a 2.0. Let me add this guy, and I'll do one thing: debug IP routing and debug IP CEF. Okay. So mic is on, guys. Interface loopback number 2. Two. What happened? Routing table we added. You see this one. CEF. 1 minute. Debug command to I know that debug. Because of the iOS version, right? Sometimes the debug is working well. Also, you know, some debug is this one CEF as well. It's not showing over there. Now let's try to show you, like, if you're going to add some route in the routing table, the CEF also will be added. If you're going to remove the route from the routing table, CEF also going to be removed. So IP CEF table. Yeah. This is like this debug is not available in the 15.0 version. Interface loopback number 2, IP address will be 2.2.2.2. See, I'm going to add this route in the routing table at the CEF table as well as CEF is also going to do, and router is also going to do. Routing table, CEF table. If I'm going to another route 3.3.3.3.3.3, I'm going to add this route in the routing table. At the same time, I'm going to add this route in the CEF table as well. Adding the route in the routing table, and I'm going to add it in the CEF table as well. Do show IP CEF. See? Done. If you see the show adjacency, I don't have any routers over there. Otherwise, I'll show you. If you see this one, I'll show you in the router number 1. So adjacency. This is my layer 2 table. So adjacency detail, if you put the command detail, what happened? You will have a MAC address information. So this is my neighbor MAC address information, right? This part. This part is my, this is my neighbor part information, right? This part is my own information, right? And this is where the Ethernet header type 2, sorry, ether type header, IPv4. So in the, so you can see the, so I'm not going to look up this is the same like your ARP table, right? Same like your ARP table, right? But this is the adjacency table of the CEF. So this is my neighbor information, own information, IPv4, ether type. So if I'm going to disable the CEF, take example, no IP CEF, what happened? My CEF table will be flushed out, but still I have routing table. Still I have routing, but I don't have a CEF. Do so IP CEF, no CEF information is there. CEF is not running. So I have disabled the CEF in the global configuration, which you see, no IP CEF. I say that you can enable by using the IP CEF. Now the CEF will be enabled, and I have all this information routing table. You can also enable and disable the CEF on a foreign interface with IP CEF, or you can disable no IP CEF. This is how your CEF is going to be work, guys. CEF is ditto like a mirror copy of your routing, ditto mirror copy. Whatever the change is happening in your routing table, CEF change will be in the fifth table. So CEF has a fifth table, at the same time adjacent fifth table is a layer 3 table, adjacency table is a layer 2 table. But still till this point, right, till this point, what is issue is happening now? We are totally relying on IP. Totally relying on IP. Doesn't matter if you have a CEF table, if you have a routing table, if you're doing the process switching, if you're doing the fast switching, doesn't matter. Your router is totally relying on a IP.
No, you said that you can disable CEF, but you can still have IP routing on it, correct?
Of course,
on the router.
Of course.
How about the vice versa? So can you actually disable routing and just have CEF?
I want to show you that one as well as. So do IP CEF, do IP root, no IP routing. See what happened. Done. Of course, this is the basic things, Swami. If you don't have a routing table, how the CEF will be built? Because CEF is routing table. Routing table is not relying on the CEF. Listen to it. CEF is relying on the routing table. Routing table is not relying on the CEF.
Okay, so there is no way that the forwarding information base can be cached without the routing table. Okay.
No.
That means we should have a high memory because we are having two copies, one in routing table and one in CEF, right?
CEF, again, can you come back?
Means we have a high memory requirement, like we have two copies, one in routing table and one in CEF.
Oh, you can see that.
Okay.
Guys, have a look at this part, right? Tell me, are you able to feel any kind of issue with the IP? Till this point, what you have learned in a CCNP. And for the kind information, I'll tell you this part, the process switching, fast switching, and CEF switching, I just gave you overview. It's totally part of the, like, you know, of CCNP classes, right? In the CCNP advanced, I discussed this part, right? You don't know. I discussed this part. CCNP. That is not sorry. Still, we are relying on the IP. Guys, tell me anyone. Do you have are you able to face any issue with the IP right now till this point? Are you able to face any issue with the IP? I have faced, but are you able to face? Have you faced ever with the issue with the IP? Okay, relying on the IP means what? That you have to do that on the later basis. Relying on the IP in the sense for what? Right? So tell me one thing. Now think about according to the ISP. What happened? Take example, if this customer has 1000 prefix and this customer has a 2000 prefix and this customer has a 3000 prefix, only 3 customer, and this is your ISP. In ISP we have multiple routers. In this case, what happened? Every single router need to maintain all this prefix information. To just forward the IP packet. Every single router needs to maintain all prefix information to just forward the IP packet. Because all customer is now relying on what? ISP. All customer is now relying on what? ISP. All customers is relying on what? ISP. Can you imagine what will be the ISP routing table of all router? Of course, right? And why do we need to maintain this information? Although why ISP is going to maintain all this information? To just forward the IP packet. Because still we are relying on what? IP must be present, man. IP must be present. And every router in ISP layer 3 lookup. Some delay will be there. Delay in the sense of what? See, two things will happen. चार डिले होते हैं, चारों का नाम बताओ. Physical layer, data link layer, then layer 2.5, layer 1, layer 2, layer 2.5 and layer 3 network layer. SI. Now, assume like this one. This is the first floor, second floor, 2.5 floor, and third floor. ये चेतन है. Right? So on a second 2.5 floor also we have a like some restaurant. On a third floor also we have some restaurant, right? And there's a girl sitting over the A and B, right? So Chetan wants to meet. So Chetan can also work with the B and Chetan can also work with the A, right? So in that case, what happened? Why should I go for the third floor? If I'm able to do everything with the second floor, right? So at layer 2.5, why should I go for the third floor, right? Lookup will happen on the layer 3, delay will be there, right? Delay will be there. So every router, if you are going to rely on the IP, every router has to perform the layer 3 lookup. Issues. Second issues. Every router has to maintain the complete routing information to just forward the IP packet. And in lookup, what we are doing? We are lookup for the how many bits? 32 bits. IP, right? 32 bits of IP I'm going to look up. And if you remember how the router is going to perform the lookup, how the router is going to do the lookup over there? Longest prefix match. So it will start from what? /32, 30, 30, 29, 28, 24, 20, 20, 18, 17, 16, 15, 14, right? Right now, all to avoid all this problem, what happened? Instead of look up the IP, first of all, instead of relying on IP, now we are going to rely on what? Some number. And that number is known as labels. This label, this number should be integer, not the float. No, number will be 20 bits. So instead of look up the 32 bits information, now 20 bits too. So IP will be 32 bits, number will be 20 bits. Third thing, no need to go layer 3 lookup. Now router will perform layer 2.5. We can see the process and resources as well. Not every router will maintain complete routing information. Only some router. This is the amazing point. And all this thing you can achieve by implementing a MPLS. The biggest myth for every person: MPLS is a protocol. It's not a protocol. It's a label switching mechanism. So by using the MPLS, what happened? Now the router will perform the late 2.5 backup, 20 bits low. Not every router is going to maintain the routing table. The biggest thing now, the router is relying on two things: rely on label and IP. The first I put the label, right, then IP. First I put the label and then IP. So now instead of relying on single IP, now the router is going to rely on which things? Label and IP. So all MPLS router is going to rely on what? This. Now MPLS router is going to rely on what? Label and IP. Now the thing is that MPLS router comes again in the new terms picture, right? Guys, in MPLS router, we have two different types of router. One we have a edge router and one we have a core router. Edge router has a connectivity with the customer and core router has a connectivity with the ISP router. So the edge router has a label information as well as an IP information as well as. Listen to this word. But core router is only going to have a label information. Okay, I'll make it very simple. Now, try to understand this thing. MPLS is not a protocol, it's a label switching mechanism. Now we have two things. One we have a label and one we have IP. Okay. Depend on the technology. For example, if I'm talking about the MPLS application in the sense of what? Where I can use the MPLS. So the thing is that you can use the MPLS in the MPLS unicast, right? You can use the MPLS in the MPLS VPN. You can use the MPLS with the MPLS T, traffic engineering, right? In the MPLS unicast, what happened? The router will have label and routing table. In MPLS VPN, what happened? Only edge router has label and routing table. But core router only have MPLS label, not routing table. This is not a part of your syllabus, so I'm not going to discuss this thing. This comes in the service provider network, MPLS. In next 10 to 15 days, we are only going to discuss about this thing. So MPLS Nicas router will have a label and routing table as well as. In MPLS VPN, what happened? Only the edge router has a label and routing table, but the core router only have a MPLS label, not the routing table. Right? So if you have a look over there, in this case, what happened? Take example. This is my core router, right? Core router that has a customer connectivity, core router, customer connectivity. Only this router is going to maintain the routing table. Routing table have this guy, routing table have this guy, routing table have this guy, routing table have this guy. They also have an MPLS table. 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 But all this person, guys, all this person, this guy, this guy, this guy, this guy, this guy, this guy, all they have a MPLS table, not the routing table. So this guy is going to maintain the 10,000 prefix. This guy is going to maintain the 10,000 prefix. This guy is going to maintain the 10,000 prefix, but not this guy. So we can see the memory and resources in ISP. And you're enabling the MPLS on an ISP side, not the customer side. Questions, guys? I'm done for today. We haven't discussed the MPLS. We'll start from tomorrow.
No questions, Law. That was a good start. Thank you.
Have you created any drive or videos for this link?
Yes. I have it, right? So you do one thing, okay? Ping in this number. I will add you. I will make a one separate grab link, okay, for MPLS. So from today onwards, I'm going to put that videos on the MPLS tab link.
Oh, did you say 10 to 15 classes for MPLS?
You want to reduce or you want to move? It's totally. I can take the 30 days as well as. Let me know.
That's yeah, I didn't know it was that long.
You want a more class?
More?
Yeah, I can.
No. More, no.
No, then 10 days will that do that.
So, but MPLS is kind of, I think it's most of these current technologies, a lot of thing is involving in MPLS
See
as
that
well.
correct. I'll tell you the market. I'll tell you the market, how the market is. Let me stop the recording. Okay, 1 minute.
So MPLS and multicast, they are asking everywhere now.
I'll stop. Let me stop recording. Then I'll discuss this part. I don't want to make a video so much.